1 minute. And 5 times 5 is?
25.
Yeah. Hey folks, welcome. It is raining like crazy here in Knoxville, Tennessee, where we filmed this from, and probably raining like crazy where you are. So I hope you're inside dry and you're watching Mathline. We want to welcome you to our show. I'm Ernie Roberts. I'm your host for this afternoon's session. We also want to welcome and invite you to call, and also let's welcome our callers, our people who are actually answering phones today from the Bearden High School Key Club. We are so glad to have them back with us. We have Kaylee and Malachi. They're waving. Make them be called, all right? So give them that number, 844-686-2378. We want to hear from you this afternoon. They want to hear from you. They've driven in and all sorts of weather and all sorts of craziness out there on the streets today to get here to work with us this afternoon. So let's not disappoint them. Let's give them a busy afternoon, make some great calls. And we had yesterday off for President's Day, and some of you have today off for flu, and who knows what else is going on out there. But we want you to give us a call anyway, all right? Give us some calls, 844-686-2378. Let us hear from you, and let's get this thing started off with our problem of the day. Problem of the day says, solve the inequality. And we've got 6 minus 2y, and that's a greater than sign. Sometimes we get those confused, whether it's greater than or less than. That one's pointing to the right, so it's greater than 4y minus 24. And we're going to solve for y. So in other words, we get y by itself. We're going to then graph that solution on a number line. We'll create that. So once again, that inequality, get that written down at home. 6 minus 2y greater than 4y minus 24 for the variable y. All right, so let's take a look at what's going on with this thing. As I said, go ahead and write it down at home if you haven't already. We've got 6 minus, it says 2y, and that is greater than, folks, that's greater than. Less than points to the left. We have 4y and a minus 24 going on for us there. So what we basically want to do is get the y by itself. I'm going to choose to put it on the left, especially since we're going to try to graph on a number line. It makes it so much easier to graph it on a number line when we have the y or the variable left over on the left. So let's go for it. Yeah, get the y's together. Why not? That's what we usually do, right? Why not? No pun intended. Some of y'all caught it, and others you're going like, oh, wish I hadn't. But let's put a minus 4y right there on both sides. We're just going to subtract from both sides because say goodbye to it over here. We're getting them together, collecting them together. Now remember, when we send it over to the other side, we have got to change signs because it's crossing over this greater than situation. We don't want to keep the sign the same. So we've got 6, and now we're going to add a negative 2, a negative 4 together. That's going to give us minus 6y. That y look like a y. And we still got greater than. That has not changed yet, okay? Some of you say, well, did that just change? No. It doesn't do that when we add or subtract things from both sides. Now we have a negative 24 hanging on for the right-hand side. Be sure to keep that negative there. Don't lose it, all right? Don't lose it. Now, from here, we've got a positive 6. Yes, I did say a positive 6 because that's a minus 6 here in the middle, but that's a positive 6 on the left end. That's what we need to move. So whatever you do, do not say 6 minus 6 at this point. That is not good news, all right? We're going to say 6 minus 6 vertically. Don't take those two together, all right? But yes, we are going to put a minus 6 underneath there, and we're going to do the same thing. We're going to use the, what we call subtraction property of inequality. In other words, whatever we do to the left side of an inequality, we've got to do it to the right, okay? That's the way it works. And again, this time they do go away, but we still have a negative 6y. Very important. Keep that negative sign hanging on. That is going to be very, very important. And then we got a negative 30 coming together when we add minus 24 minus 6, or negative 24 minus 6, however you want to look at that, that gives us the negative 30. Now, where do we go from here? This is where it gets critical. We are going to divide both sides by negative 6. We are going to slide that negative 6 right through there. What just happened is we have now gone from, well, a negative and a negative now to two positives. Because what happens when you divide? Yeah, when you divide a negative 6 into a negative 6, they're gone, right? And you're left with y. On the right-hand side, you're left with 5. And all of a sudden, things happened. Anytime, folks, anytime we divide by a positive number, nothing happens. It's just rote good stuff. But if we divide by a negative, not only do the signs change, also, because of those signs changing, the inequality shifts direction. You say, whoa, that's pretty big. It really is, because now we're looking for answers that are going to be less than 5 that make this true. Now, there are many answers. There are, infinite number of answers if you really want to get right down to it. But let's draw a number line so we can illustrate all of those answers rather than trying to mark them all. And I know some people go, well, you can mark 4 and 3. Well, yeah, but you also got, what about 4 1/2, 4 3/4? And then get beyond 0, all those negatives and fractions and decimals and irrationals and, oh my goodness, all sorts of real numbers. So we are going to look at, we're going to spot somewhere here, we're going to call it 5. And because we don't have a greater than marked onto here, we're going to put an open circle. We want to get very close to the 5. We want to get as close as we can, which means perhaps 4.999999998. That's one of them, but you can go even closer. In other words, you just basically, this is just kind of this little, one stinky little open point. That's why we put an open circle there. So Ernie, it looks like it took a lot more than 1 point out. Well, it emphasizes that we do have, we're not going to include the 5, okay? That's just what that is about. We are looking to shade to the left because now we're in less than mode. And it's another good reason why we want to make sure our students in middle school and even in elementary school, when you start seeing these things, you understand which is greater than, which is less than, because it makes all the difference, whether you're going to the left or whether you're shading to the right and looking for, well, incorrect numbers if you forget to do the twists there, all right? So let's check real quickly. I do like to check. First of all, we know if we put a 5 in there, since that's our boundary, if we put a 5 in there, we're going to get these sides equal to each other. Let's see what happens if we put a 5 in the original. Go back up here just a little bit. How about it? 6 minus 10. We're going to multiply first, remember. So we say 2 times 5, which is 10. Then subtract it from the 6. Well, that's negative 4. Keep that in your mind. Over here, we're going to multiply. We're going to say 4 times 5, which is going to give us 20. And that's going to give us 20 minus 24, which gives us negative 4. So that tells me that's the boundary. That's the boundary we're setting up, but we don't want to include it, so we put the open circle there. So that part's good. Now, I have chosen all these numbers to the left. If it works for one of those numbers to the left, since I've got my boundary set correctly, it's going to work for any of them. So let's pick something easy. You say, what would be easy? How about a 0? 0's to the left of 5, isn't it? So let's put a 0 up here and do a quick check. And again, these are to make sure you're accurate. And on this side, I've got 6 minus 0, yes. Over here, I've got what? 0 minus 24. Well, this gave me 6 over here. This gave me negative 24. Definitely, we can say without a shadow of a doubt that 6 is greater than negative 24. So we have shaded it in the right direction. All is good. All checks back. The number line illustrates all those possible solutions. Whew, almost as close as possible as you can get to 5. And anything to the left, whew, to infinity, works to make this a true inequality. So there's your problem of the day, and hopefully that was a helpful explanation for you also. Again, one of those things, you got to watch your signs so much and watch the inequality. Make sure it shifts only when it needs to shift. And that's when we divide or multiply by a negative number. Now, let's shift gears a little bit. We've got some folks from Bearden High School out there waiting to hear from you guys. Give them some calls, all right? 844-686-2378. We want them to feel like it was worth their time to come out. They've come out pouring rain this afternoon, and they're here to help us and serve you. So give them a call. They will send you in turn right in here. We'll talk live on the air, and they're not going to solve the problems for you. No, don't worry about that. You'll give those, we'll pipe those into me, and we'll work together live on the air to figure out what kind of math questions and answers you have for me to work with today. but you got to give us a call, all right? So do that. If you haven't already got us in speed dial, put us there, all right? 844-686-2378. While we're getting there, let's take a look at a little problem here that's an interesting moment here. And if you got a graph paper grid, this works so much easier, I think. If you don't have a graph paper grid, you just got to be careful. How's that? Let's see what's happening. It says, write the equation of a line with x-intercept of -4 and a y-intercept of -2 in slope-intercept form. You say, well, Ernie, what's that all about? Well, it's about y equals mx plus b, I believe, isn't it? So here we go. Y equals mx plus b. That's slope-intercept form. We tend to use that expression. Where m is your slope, b is the intercept. That's why we call it slope-intercept, because slope comes first, and there comes the intercept. And by the way, it's not just any intercept. It is your y-intercept. So we already have the b. All we got to do is figure out what's m. So either way, this is really kind of an easy problem, I think. So what we need to do is figure out that slope. And our slope formula, as we all remember, those two words, rise over the run. And rise is the difference in y's, and run is the difference in x. And some of you are going like, we don't have but one x. We have an x-intercept, and we have a y-intercept. Well, we have a coordinate when we talk about those points. So let's talk about x-intercept. That means x is -4 when y equals to 0. You guys who are in pre-algebra, algebra 1 out there, you've heard that. Now you hear it again here on Mathline. The next tool of this trade is the point 0, -2. Because when x is 0, y comes out to be -2. That's what we mean by y-intercept. So there we go. We have 2 points. We can make rise and run happen. We're going to also put it on a graph here in just a second and show you how even, I think, more quickly things can be done with the good old slope-intercept form, just getting it off your graph. So let's play it out here. We've got the rise, which is going to give us 0 minus a -2. How about that? Underneath that, we're going to do the run, which is the x's, and we're going to put a -4 subtracting 0. And at this point, remember, when we subtract a -2, it's just like adding 2. Now, that's where you got to be careful. So we're going to have 2, and we're going to have -4, which we all love to reduce. Yeah, I like to simplify, right? We can divide both those by 2, and that's going to give us a -1/2. So it looks like our slope says y equals -1/2. We attach the x. That's because we always put there. We'll take a lower third just a minute, guys. Thank you. And we will put a subtracting of 2 there. All right, and that's the equation. Now, let's pull in. Just take me out for just a second, if you will. Take me out. Maybe we'll get there. Just take a, yeah, there we go. Good, thank you. We're going to bring in some graph paper. I think I probably should have spelled that out a little bit stronger there. But let's put these 2 points on the graph on our grid. So we'll play it out here. And let's see where they land. So we got -4, 0. You got 0, -2. Bring along Curious George here to make a line for us here. And I see, it is really looking good, isn't it? There we have it. And another little point going on down through here, something of that nature. But look what we have here. We have a down 2 over 4 slope situation. So that tells me, that's my slope, basically -2 over 4, which was -1/2. So far, so good. And then there's your point. So it's really easy to name that. You know, count the blocks, get the slope, and then there's the y-intercept. You're good to go. So another option to put down, yes, y equals -1/2 x minus 2. And you have it. And speaking of having, I think we have a caller waiting in the wings. So welcome to Mathline this afternoon. Who am I talking with?
Anna.
Is it Jana?
Anna.
Anna. Anna, we're glad to have you with us this afternoon. Where are you calling from? What city or what county?
Northwest.
Northwest. All right. Well, we're glad to have you with us today. All right. And what kind of problem have you got for me?
Slope.
It's on slope. Well, good. Perfect. What kind of problem? Can you read it out for me or give it to me and give me a feel for what we're going to do?
Y over 2 plus 1 equals 2x minus 1.
Y over 2 plus 1 equals what over there? 2x minus 1. 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 2x minus 1.
equals 2x minus 1.
2x minus 1. Okay, check and see what I've written. Is that what you've got?
Yes.
All right. Are you trying to get y by itself? Is that the game plan here?
I think so.
Do you have any instructions with the equation? Does it say like to find an intercept, or does it say find the slope, or does it say write the equation in slope-intercept form?
It says intercept form.
Okay. So we're you're looking for. It sounds like so you're looking for intercepts. Is that what we're doing here?
Yes.
Okay. All right. So in looking for intercepts, basically we mentioned that just a minute ago with that x and y intercept situation. Let's do a little maneuvering on this. Okay. I'm going to move these 1 over here. Put a minus 1 over here. And let's see, I get y over 2. You see that where I just did that?
Mm-hmm.
Equals 2x minus a 1. Okay? Now, what we're going to do is we're going to see what the intercepts are for these situations. And you may be looking for doing a little bit of kind of a form here, but let's see what's happening. I have, I may want to get rid of these this 2 here because we don't like the fractions, but we don't really have to, okay? So first of all, let's allow x to be 0. Does that sound good?
Okay.
So we're going to let x equal 0 because that's what an intercept does, all right? So we're going to have y over 2 equals 2 times 0 minus the 1, okay? And what's 2 times 0? That's easy, isn't it?
0.
0, exactly. So we got y over 2 equaling a negative 1. So all of a sudden this looks really easy to figure out, doesn't it?
Yes.
Just multiply both sides through by 2, and you're going to get y equals, it looks like, a negative 2. That's sort of like my problem was just now, wasn't it? So there's one of your intercepts, and we'll put a coordinate on that here in just a second. And I'm going to go ahead and put it right up there. That's 0, negative 2. Put that negative in there. You see where I got that?
Yes.
So there's one intercept. Now let's go to the other side. We're going to rewrite, start over again, equaling 2x minus 1. And in looking at that situation, I'm going to put a 0 in the y, okay? Because I did 0 for x, right? So this time we want to do 0 for y. And you know what? 0 divided by 2, if you have nothing, you split in half, you still got nothing, right?
Yes.
So that's going to be a 0, we're going to say, equaling to 2x minus 1. I need x by itself, all right? So I'm going to kick that little 1 over here. It's a minus 1. I'm going to add 1. See where I'm going?
Mm-hmm.
And that's going to give me 1 equaling to 2x. Be very careful because we're going to divide by 2.
Okay.
Because the reason what we got to do is got x by itself, right? We want to clean up x. So the 2's go away, and I have a 1/2, and that's okay. So we've got x equals 1/2. So the intercepts that I'm seeing, and I think this is what you're asking, I hope it is 0, negative 2, and 1/2, 0. Does that help you a little bit? Does that make sense?
Yes.
Okay. And one other thing that we could have done that may have helped us a little bit more was to clean up the 2 to begin with. And we could have gotten or moved the 2x over here, all sorts of things where you've got a standard form. But it sounded like when you were talking about the words intercepts, I just think we could just tackle it right where we are. We've got ability to put zeros in here, especially once we got it to here. Pretty easy to do. Okay? Hey, thank you for calling in, and also tell your friends about us, okay? And make sure they're watching and get a chance to do some problems with them too. All right, thank you. I understand I have another caller waiting for me. Welcome to Mathline this rainy afternoon. Who am I talking with?
Hi.
Hey, who am I talking with?
Henry Polisi.
Well, glad to have you with us this afternoon. And can you tell me where you're calling from? What city or county? Maybe even what state?
Knoxville.
Hey, Knoxville. So good to hear from you, Knoxville, Tennessee. What kind of problem have you got for me this afternoon? And if you'll mute your TV down just a little bit, I'm hearing a little feedback.
6.
Okay. Yeah, go ahead and mute your TV, all right? That means turn it down a little bit, and that way you can just listen to what I'm saying, because I think you're waiting for feedback. Yeah. We'll try again. I got a 6. I got that much. There we go. I think that sounds much better. Are you back?
Uh-huh.
Good, good. And what?
One more minute, please. Mama, I'll already done.
Okay, let's. Got a 6.
And decimal 6 tenths 300 tenths 6,000.
Okay, so let's go.
Divided by
Okay,
48
okay,
equals.
so let me go back here again. You got 6 and you got 0.6, is that right?
Yes.
And there was a 3.
No, 6.
Oh, just 6.6. That's it.
Then 3.
Are we good so far?
Then 6.
Another 6. And another 3?
No.
Okay, all right.
Divided by.
All right, divided by?
That was 6.
How much?
Okay, that was 6.
Another 6?
Divided by. Mommy.
Negative 6?
Divided by.
Mm-hmm.
84.
54?
84.
84. All right. Now look at what I put on the TV screen. Now, are we still pretty close, or do I need to change any numbers?
Okay, nope.
Are we good? 6? And you got a decimal? 636?
This is his mother.
Yes,
Okay, which one are you reading to? Right there. Okay. Okay, Ernie.
Yes.
6.636
Good.
divided by 84 equals.
Equals. All right. So basically, it's just a nice division problem going on here then. Now, is the 84 inside? Do you have it written out like this with the divided by symbol in the middle, or do you have it 84 on the outside and dividing into 6.636, or is it
6.636 with the division sign?
and 84?
84 equals.
So it looks just like what we've written up here. Okay, all right. So what I'm going to do, I'm going to take that 84, I'm going to put it to the outside, and we're going to do some division, okay? Now, I'm thinking hard here because this one is, I think it's just a little out of the reach of where I want it to be, but we'll see what happens. I am thinking that, first of all, how many times will 8 go into 66? That kind of gives me a start, gives me a chance to get an estimate going here. And I want to see I think it's 8 with a little more, okay? But I want to see what 84 times 8 is going to give me. All right? You with me so far?
Yes.
And because that's what we're going to subtract out of here if we can. Because remember, it's kind of like that show The Price is Right. You can't go over the price. You've got to stay under it before you can subtract with division or equal it. It's okay if you nail it. That's good. But if you've got a little more than that, you've got a problem. So you've got to lower your numbers. And I think we're going to have a little more than we need here. I'm catching, wow, what am I catching? I'm catching 32. And that's going to give me 67. I've got 672. See where I got that?
Yes.
The problem is, I can't subtract 672 from 663, can I?
No.
No. So what I need to do is drop that 8 to a 7. And we're going to check it out. We're going to see what happens with it. It's going to be nicer, I guarantee you. 4 times 7 is going to give us 28. I'm going to put a little 2 right up there. And 8 times, first of all, we say 8 times 7, because that's what my dear Aunt Sally tells me. It says multiply, then you can add the 2. And we've got 56 and 2, which gives us 58. That's a little bit better. It's still quite a bit underneath, but it's what we can use. You see we're going to line it up now?
Yes.
All right, let's subtract. And this is where we kind of got to be careful. We're going to, because we can't take 8 from 3, we can't take 6 from, we can't take 8 from 6, so we got to come over here and take a little borrow action here. And that's going to make that a 16. I'm going to do the old-fashioned borrowing routine. Basically, we're regrouping. We're borrowing one of the places here, and we make that into 10 plus 6, which is 16, which is good for that, but it's still, we need a little help here. So let's go one more notch. We'll take that down to 5 and make this 13. That got kind of messy, didn't it? So 13 minus 8, I can do that. That's going to give us 5. You with me? See where I'm going? We're just doing subtraction, right? And we're going to have 15 minus 8, which is 7. We've got nothing left over there, so we bring down the 6. Whew, it looks like maybe 9. I don't know. Let's see what 84 times 9 will do for us. I think we've got a good number going here. Oh, by the way, we needed to put a 7 somewhere here. How about right there? And then we've got this, so that's going to give us 6. Carry my 3. I'm seeing 756. That's good news. You know why? Because we have nothing left over. So far with me?
Yes.
Put a 9 up there. And I have a decimal that's going right there, but I have a space. I have an open space. So what do I need to do? Put a 0. And that's what I see is, looks like 79 thousandths. 0.079 should be where we end up. Does that sound good to you?
Yes.
All right. Hey, thank you for calling in this afternoon, Knoxville. Oh,
I got one more.
I tell you what, if you'll hang on or you'll call me back, I'll work it after the show. They're telling me I have to get off the air. How about that? But you've done great. Thank you for helping us today. Give us a call. Give a call right back. Those folks from Bearden High School. Bearden, thank you all for being here with us today. All right. That was Keely and Malachi from the Bearden High Key Club. And folks, we'll be back again tomorrow, right, ready to go again, and we'll see you then.
People. Okay, I'll leave the phone right there. I'll listen. Okay, and write it down.